Military hardware represents the physical, mechanical embodiment of policy. The blueprint for this translation is MIL STD 1472H, the Department of Defense's absolute standard for human engineering. It establishes human engineering as one of the 7 core domains of human systems integration. This framework forces designers to treat the operator as a critical subsystem. The impetus for the standard's radical H revision came from a sweeping 2015 mandate issued within the Pentagon. Secretary of Defense Ashton Carter issued a memorandum directing the full integration of women into the armed forces. The directive instructed the military to execute plans opening all occupational specialties, career fields, and branches to female service members. Declaring a career field open on paper is one thing. If the physical geometry and sheer weight of legacy hardware actively prevents a newly diverse force from doing the job, the policy fails. To implement a mandate, engineers had to rewrite the baseline assumptions of military hardware design from the ground up. This directive is explicitly codified right in the foreword of the 1472H document. It dictates a strict new operational requirement. All newly designed equipment must conform to a mixed-gender lift capacity. In practice, this means engineers must identify and remove unnecessary physical barriers to military service, accommodating the broadest possible user population. For decades, legacy operations relied on brute force and ad hoc multi-person lift teams to handle heavy gear. Now, non-compliant equipment requires deliberate engineering mitigations. Contractors must redesign systems to reduce overall weight, optimize the placement of lift points, or formally increase the number of required lifters in the official documentation. This standard treats the human body as a fixed, non-negotiable subsystem that the mechanical hardware must accommodate. A persistent misconception in systems engineering is the belief that hardware can be designed up to the maximum physical limits of a highly conditioned soldier. Relying on top-tier athletic performance simply to operate standard-issue equipment introduces systemic fragility into the military machine. Exhaustion, injury, or natural demographic shifts can render the equipment useless. The foreword attacks this directly, stating, "Military physical fitness testing standards are not appropriate for use in design criteria or to quantify human performance limits." The logic here is absolute. A physical fitness test evaluates the capability of the soldier. Design criteria evaluate the viability of the machine. Ignoring this distinction has severe, career-limiting implications for service members who are otherwise perfectly suited for their technical roles. When hardware is poorly designed, procuring activities can define a target user population that disproportionately excludes highly capable personnel from completing the mission. Treating the human operator as a fixed constraint extends across the entire standard, dictating everything from digital interface scaling to the exact torque required to turn a ship's valve. If a user cannot operate a system effectively because it requires peak athletic output, the design has failed as an engineering solution. Moving past the philosophy of the foreword, the standard enforces these rules through strict mathematical metrics. As this document shows, the standard outlines the exact mechanics of human strength. Under Section 5.2, it dedicates rigorous guidelines to handling capacity and specific lifting limits. Compliance isn't achieved by simply capping the raw weight of an object. Engineers must calculate specific spatial variables during the handling process. To determine the maximum design weight limit, 2 core variables are applied. The H dimension measures the horizontal distance from the lifter's center of gravity to the load, while the V dimension measures the vertical height from the deck. As that horizontal distance or vertical height increases, the required exertion force spikes. A load that is manageable close to the chest rapidly exceeds the mixed-gender baseline if the user has to reach outward or upward to position it. When a load pushes the force requirements past those limits, the standard dictates immediate mechanical interventions. Engineers must split the load into modular components or position recessed grasp areas at optimized heights to force the H and V variables back into acceptable ranges. This optimized state brings the equipment into the central 90% accommodation envelope, ensuring it is functional for the vast majority of the population. Inclusive design is an objective, rigid geometric formula applied to the hardware to ensure it fits the widest possible distribution of human anatomy. but the realities of systems engineering in combat environments frequently collide with these geometric ideals. There are scenarios where extreme friction, pressure, and the raw laws of physics outvote demographic accommodation policies. Heavy armor plating, large caliber ammunition, and high-pressure steam valves cannot always be made lighter or smaller without compromising their core lethality and survivability. For these specific cases, MIL Standard 1472H provides a formal trade space exception, allowing designs to exceed the standard anthropometry or lifting requirements. This programmatic exception is highly scrutinized, requiring documented proof of technical necessity rather than engineering convenience. To bypass the baseline standard, contractors must submit rigorous documentation to the procuring activity, proving that the physical limits are unavoidable. Exceptions are granted only when technical viability completely precludes full accommodation. Triggering this design exception requires meeting 3 strict criteria, establishing a heavy burden of proof. First, they must prove a clear operational need for the design to exceed requirements. Second, demonstrate no viable alternative exists, detailing why mitigations are cost-prohibitive. Finally, provide evidence-based rationale proving this does not discriminate by gender. This final step forces program managers to confirm that the unyielding hardware will not deliberately bottleneck career advancement for the personnel who cannot operate it, requiring mitigation plans if it does. Ultimately, the standard is driving toward a specific objective: achieving operationally relevant and gender-neutral standards across the entire Department of Defense. MIL Standard 1472H strictly enforces the balance between validated military requirements and the broadest possible demographic utility. True human factors engineering mathematically optimizes the personnel-equipment combination, ensuring the hardware functions as a precise tool for the warfighter.